Okay, we have 4 problems here. Now, with these problems, I'm seeing a lot of numbers. I'm even seeing some variables here. This looks like a lot. Here's something that's going to help me. I call it Gemma, right? And this is a shorter, easier way of remembering order of operations. You might have heard of order operations before, maybe PEMDAS or GEMDAS. I even once heard someone call it BODMAS, right? This is a little bit shorter. We're just going to use it as a reference as we work through. Here, I'm going to start with this one. Now, I'm seeing a lot of different symbols here. What I'm going to remember first is this G for grouping. We see this grouping here, and then I see another set of parentheses here inside the brackets. Let's break this down. I'm going to start with this over here, because this is in its own set of parentheses. G for grouping is first. I'm just going to do 4 plus 2, which is 6. That's done. Here, I'm going to copy the minus sign. Now, with these brackets and the parentheses, the way this works is you go inside out. So we have 2 different grouping symbols here. I'm going to start with the grouping symbol on the inside. Once I'm done with that, then I'll work on what's inside the brackets. Okay, so here I'm just going to copy the brackets at first. This is not in any sort of grouping symbol. Here I'll just write 5 squared. We got my division sign. But now, with this parentheses on the inside, I'm going to do 2 plus 3, which is 5, in brackets there. Now this is just, I can see inside here, I'm going to be doing whatever inside here because of grouping being first. Okay. So, how do I do that? Well, inside here, you'll notice that we have a couple different symbols. I'm going to go back to my reference. We were talking about grouping before. Next is this E for exponents. So I have a couple things here, but I'm noticing there's an exponent. I have to do that next. I already worked on the grouping. Now I got the exponent. So whatever inside of a grouping symbol follows the order of operations. We did exponent. You'll notice this doesn't have anything about division. I'm grouping division with multiplication because those 2 things are opposites. Likewise, with addition, I would group subtraction with that. So multiplication goes with division, addition goes with subtraction there. Those things go together. So 25 divided by 5 is 5. So we just did the division there with the m. And now 6 minus 5 equals 1. Great. All right, let's look at this next one. Well, this one looks a little bit different here, right? A square root symbol, we would consider a grouping symbol. So we're still using our handy reference here, right? I'm even putting a multiplication symbol here just because it helps me. I see that they're next to each other, so that means they're being times. 50 minus 1 is 49. Now, I might be wondering, do I multiply 3 and 49? Do I take the square root? You can think of a square root, along with being a grouping symbol, for whatever's underneath. It's also like an exponent. In fact, if you did 49 to the 1/2, it would be the same thing. So I'm not going to multiply because that comes after e. So the square root of 49 is 7. 3 times 7 is 21. Here we don't have any addition or subtraction, so we're done. All right, these bottom ones I'm noticing has variables. That means we're going to have to plug in these variables into the expression. That's the first thing I'm going to do. So here it says z is 7. We got x being 1 and y being 3. Now, if you compare this problem to here we had a division symbol. A fraction bar is also a division symbol. But I'm also noticing a lot on the bottom here. So fraction bar means division, but it also means that it can be thought of as a grouping symbol, meaning everything on the bottom we have to do first. So we're going to have 7 over 4. Now, if 4 went into 7, I might divide here, but 4 does not go into 7. I'm actually going to leave this as a fraction because we can't simplify it anymore. All right, Again, we see some variables. We're going to plug in those values. 4 times negative 1. Remember, when they're next to each other, it means times. Plus 3 to the 4th power. Right? Grouping goes first. We notice that the exponent is on the outside. So I'm not going to worry about that because we're doing grouping first. Got a couple operations in here. We're going to do the multiplication first. 4 times negative 1 is a negative 4 plus 3. Again, I have that exponent, but it's outside of my grouping symbols. So I'm going to do this addition here. Negative 4 plus 3 is negative 1. All right. Now I'm finding negative 1 to the 4th power. Anytime you have an even number, for an even number exponent for a negative base here, your answer is going to be positive. If this number was odd, it would be negative. I'm going to write it in expanded form to show you. So, to the 4th power means I'm multiplying by negative 1 4 times. Remember, 2 negatives make a positive, right? And likewise, as I said, if this was a 3, for instance, an odd number, you would have a negative 1 as an answer. But we're multiplying it by the 4th power, meaning my final answer, I'm going to write over here, is just 1. Okay? So these are a few examples, and you're going to see similar examples on the Google form.